Okay, we're now going to move from talking about logic to talking about scientific reasoning. First up, we'll set out some background. That's what we'll do in this sequence of videos. And then we'll look at different conceptions of how scientific reasoning works. So the first bit of background we need in place is what a theory is, a discussion of what a theory is. Now there's a variety of conceptions of what theories are. We're not going to work through each of those conceptions. Instead, we're just going to adopt one uncritically. I'll say, here's how we're thinking of theories. And the reason we can do that is, no matter which conception of theories you adopt, the range of choices for how to think about scientific reasoning is the same. Put another way, each view on how scientific reasoning works is consistent with any given view of what theories are. So, what are theories? Well, here's the view we're going to work with. Theories are propositions that, if true, explain some target of explanation, something you're trying to explain. Now, this invites further discussion of what explanation is, and we'll look at we'll discuss what scientific explanation is down the line. Next up, what is the goal of a theory? Well, we're going to take the goal of a theory to be true. Now again, that's controversial. You might think the goal of a theory is to work well enough, to allow us to make successful predictions, to make us happy. There's all sorts of possibilities. But we're just going to take a theory's goal, first and foremost, to be true, where a theory is true if and only if the propositions that comprise it are true. Now, this invites some further discussion of what truth is. As I've said before, we're not going to discuss that in any detail. And again, just like we don't need to specify which conception of theory, just like we don't need to go through every conception of theories, because it doesn't really matter which conception we adopt, we're going to have the same range of choices for thinking about scientific reasoning available to us. It doesn't really matter which conception of truth we adopt. We're going to have the same range of choices for thinking about scientific reasoning available to us. Now, as I've said before, I like the correspondence theory of truth, according to which a proposition is true if it corresponds to the way the world is. But you can plug in your favorite conception of truth and everything will stay the same. Okay, so a theory is a proposition or set of propositions that aims to explain some target of explanation, and the goal of a theory is to be the true explanation of that target of explanation. Often a theory is a molecular proposition, meaning there's more than one proposition, so it's a set of propositions, not just a single one. A theory aims to explain a wide range of targets. It aims to explain many, many different targets, not just a single target. Not necessarily, but quite often. A theory often has multiple non-trivial implications. That is, the theory is such that if it's true, thus and such must follow. That is, the world must be various ways. Now, I put implications in scare quotes because we're not necessarily talking about the kind of implication we talked about in logic. That was called material implication, where you have material conditionals like P arrow Q, which means P guarantees you're going to get Q. And if you have Q, Q is a necessary condition for P. In order to get P, you have to have Q. Often in science, we don't have implications quite like that because there's too many exceptions to any statement of the form P arrow Q. So instead, when we talk about implications, we'd say a theory has multiple non-trivial implications in the loose sense that it will increase the probability of certain states of affairs. And for now, I'll represent that with a dashed arrow. This means P increases the probability of Q if you have P here and Q here. Okay, what theories are not? Calling something a theory is not saying anything about how confident you are that it's true. If you're 100% confident that something is true, it can still be a theory. If there's an explanation and you're 100% confident it's true, then it's a theory. Calling something a theory is not saying anything about how widely accepted it is. So everybody accepts 1 + 1 = 2, we could call that a theory. That's perfectly fine. That's in contrast to sometimes people in ordinary language will say, ordinary discussions will say, well, that's not a fact, it's just a theory, right? And they're denigrating theories. They're saying theories are something that is sort of inferior to facts in some sense, or that they're controversial, or maybe we shouldn't be confident that it's true. That's not how we're using the word theory. So we're just using a theory to mean a proposition or set of propositions that aims to explain some target of explanation. The theory, that leaves open that the theory is true. It leaves open that we're entirely confident that it's true. It leaves open that it's widely accepted. It also leaves open that it's false, that we're not entirely confident that it's true, and that it's not widely accepted. You can call a proposition that you doubt a theory. You can call a proposition that you're confident is true a theory. You can call a proposition that is highly controversial a theory. And you can call a proposition that is almost entirely uncontroversial, or even entirely uncontroversial if there was such a thing, a theory. For example, you can call aliens abducted Elvis a theory, but you can also call Einstein's theory of universal gravitation a theory? Accordingly, dismissing a proposition by saying that's just a theory is a mistake. Okay, I have a theory right now that there's mustard in my refrigerator, and I'm very confident that that's true because I was just in there and put some on my salad and then put it back. Of course, there's some ways it could go wrong maybe, but I'm as confident that there's mustard in my refrigerator as I am of anything else, and I'd still say it's a theory. So we call a proposition a theory to mark that it's under consideration, that we're thinking about whether it's true or false, that we're interested in assessing its truth value, not to say that it's unlikely to be true or any such thing. Okay, next up, observations. Roughly, an observation is an experience or set of experiences of the perceptual kind. So like you look at a desk and it looks a certain way to you, that's an observation. You hear some chirping of grasshoppers or cicadas, they sound a certain way to you, that's an observation. Now, some people prefer to think of observations not as experiences, but as events where you're sort of directly in contact with the world. That's fine, but again, for our purposes, it's not going to make a difference which conception of observations you adopt. So we're just going to think of observations as experiences of the perceptual kind. Now that invites the question, what is a perceptual experience? And that's a really interesting and deep question with a lot of discussion to be had, as are all of these kinds of questions. But we're just going to assume that perceptual experiences are things like seeing, hearing, feeling, smelling, tasting, and maybe a few other things. Next up, confirmation and disconfirmation. So an observation confirms a theory if it suggests that that theory is true. Now, this notion of suggesting a theory is true is very loose. You might say if it increases the probability that the theory is true. We're just going to leave it with as suggests that the theory is true. And an observation disconfirms the theory if it suggests that that theory is false. So again, you might prefer an observation disconfirms a theory if it lowers the probability of the theory. We're just going to stick with suggests for now. Now, this invites a question, how do confirmation and disconfirmation work? That's going to be the heart of scientific reasoning, and we're going to get into that. But right now, I just want you to have this sort of loose idea that confirmation is suggesting a theory is true and disconfirmation is suggesting a theory is false. So these are really the key bits to have in place. We're going to talk about some more things, but these are the key ideas. You have theories, observations, and observations confirm or disconfirm theories. Next up, experiments. Roughly, an experiment is just an attempt to make observations in a systematic way so that you can confirm or disconfirm a theory rather strongly. That is, you can get a strong suggestion that the theory is true or a strong suggestion that it's false. Now, there's a lot to be said, of course, about how experiments work, about control, naturalistic experiments versus, laboratory experiments. How exactly experiments work is a very interesting question. We'll talk a little bit about that. But I just want to have the idea of experiment on the table. Next up, probability. Now, we're going to talk more about probability than we talked about any of these other bits that you need in place for scientific reasoning. So we're going to leave it in another video. So we'll start the next video by talking about probability.